for the second one, okay, again, for this function, we need to see where it's increasing. Okay, I've drawn the graph out on the computer, and this is what I've got here. Okay, so we can see now, okay, with this cubic graph here, where it's increasing. Now, I hope you could see here, this obviously part here from the minimum all the way to infinity is increasing there, but of course in the middle section here it's actually decreasing, isn't it? Because it's going down as x increases. It's the curve is going down, isn't it? But it's obviously increasing then before then, okay, all the way to minus infinity, okay, all the way up to the maximum point. So we're going to have two separate ranges here of solutions. That's where we're going to look at where the function is actually increasing, okay, and the middle section here the function is actually decreasing, isn't it? It's falling, so we're not going to have that as part of our solutions. So what we, again, thinking back to what we saw in the first question, we just got to establish where the gradient is positive, isn't it? Okay, that's the interesting bit there, because that's where the graph is increasing. And the same here, the gradient is going to be greater than 0, positive. Here, of course, the gradient is going to be negative because it's sliding down. We're not interested in where it's decreasing, only where it's increasing. Okay, so there's my function here, so I've written it down here. And remember then, because we're interested in when the gradient is greater than 0, I'm going to do f dash of x, okay, which is, remember from before, is just another way of saying dy by dx. So I differentiate this, I get 3x squared, okay, bring the 3 down, reduce the power by 1, minus then 18x, bring the 2 down, becomes 18, and then plus 15, 15x becomes 15, and the 10 disappears. So we say then, for an increasing function, okay, for the increasing function part, we need the gradient, f dash of x, to be positive. So in other words, 3x squared minus 18x plus 15 to be greater than 0. And what we've got then is a quadratic inequality. Now, we've seen before how to solve quadratic inequalities, okay? But of course, the first thing you'll do is, before we solve it, to see is there any common factors in here, to see if we can make it easier for us. And of course there is, isn't there? We could divide by 3 here, okay? And we'll get x squared minus 6x plus 5 is greater than 0. Okay, and then we're going to solve it. Okay, so to solve this, we look at the critical points, don't we? We consider where the actual quadratic here is equal to 0. Okay, now this goes back to, as I said, to the one of the first topics we did. Okay, so we look at where it's equal to 0, the quadratic, and then we solve it. So, two brackets, x in both, and we need two numbers that multiply to give 5, add up to give minus 6. Well, the only two numbers that multiply to give 5 are 1 and 5, and to get them to add up to give minus 6, they need to be both minus, and when you multiply them, that will add up to, that will multiply to give plus 5, won't it? So we've got that equal to 0. So when you've got two brackets times together equal to 0, either the first bracket is 0 or the second bracket is 0. So x minus 1 will be 0, which means x is 1, or x minus 5 is 0, which means x equals 5. Okay, so those are my critical points. What I'm going to do then is I'm going to draw a quadratic, okay, graph. So smiley face, okay. And we know it goes through the x-axis at 1 and 5, okay? So 1 and 5, so if I turn that around, easy for me to draw a smiley face. Okay, not the best drawing, but it'll do, it'll do. Okay, now going back to the inequality, yeah, I was trying to solve before. Got this one here, yeah, so basically it's x squared minus 6x plus 5 is greater than 0. So I'm interested in when the quadratic is positive, so it'd be positive here, positive here. In other words, when x is less than 1, okay, or, it's important to have the word or there because they are different regions, okay, they don't go together. X is greater than 5, so x is less than 1 or x is greater than 5. And if you go back to the graph, of course, okay, of course that does answer our question perfectly, doesn't it? Because it's increasing here when x is actually less than 1, so that is 1 there, isn't it? Okay, and then the other situation as well, it's increasing when x is greater than this value here, which of course is 5 on my graph. So it works.